Hi, my name is Amr Thabit. I'm a malware researcher and the author of Mastering Malware Analysis. And today we are going to talk about fileless attacks. Fileless attacks are type of attacks that don't really create files on disk or avoid creating files on disk as much as they can. It might be the initial access is a malicious document with macro, but the remaining parts are all without any files. And these fileless attacks are able to bypass most of the file signatures type of detections, and they are able to bypass also a lot of different detection tools that are on the endpoints. So today we're going to look into how these attacks look like and how they can abuse Microsoft legitimate products to be able to execute this memory snippets, this code snippets in the memory, and able to allow the attacker to take over the whole system. We will be looking at an attack that was uncovered by Trend Micro, and this attack it's a real attack where the attacker was able to, out of just one registry entry, we haven't seen the initial access in this case, but from a registry entry he was able to load multiple stages of a malware and run his backdoor to take over the whole machine just using the memory from one step to another. Let's take it. So the malware starts with abusing one of the Microsoft signed applications, which is Rich SVR32. It's a Microsoft signed legitimate application that is in every Windows, and it uses that application with the specific parameters to be able to execute or download and execute a specific XML file. What is this XML file is called? It's called com scriptlet. This is an XML file that might include JavaScript code, and it represents something that's now a bit obsolete, which is COM objects. Microsoft always have backward compatibility. That's why it is still allows you to download and execute this type of XML files or this type of COM scriptlets. Using Microsoft or abusing Microsoft applications to download, execute, or decrypt, encrypt a malware is a very known technique called lolbas or lolbins. Lolbas or lolbins are basically the Microsoft binaries that you can abuse for your own advantage. Anyway, so this XML file looks like this. It starts with it's an XML version, scriptlet. It says it's a COM scriptlet, and there's some information about what this program is and its ID and so on. And then it does have the script up here. This script is very obfuscated. I have deobfuscated it before, and it looks kind of like this. So malware equal new active X object, which is basically opening a shell. So basically it's opening a shell, and then it runs or like a command prompt, and it executes that specific command. This command is partial.exe, no profile, bypass any restrictions, and then executes this specific code. First, it ignores any certification error. Looks like the malware website might have an SSL certificate that is self-signed. And then they use IEX, which means invoke execute, which means execute the code that's being downloaded from here. So it creates like a web client, it downloads that code, and basically it executes it, and that's basically the whole process. So basically downloads a PowerShell code and executes it using IEX. This PowerShell code looks like this. Here. So that is the PowerShell script. What this script does. So we see here it starts with a variable name called pscript, and it converts all of that text from base 64 to something. So let's take a copy of all of this and convert it from base 64. Let's follow him step by step. So we copy all of this. I'm showing you how malware analysis generally look like. So we go here and we go inside a website called cybersecurity. You can basically download it to your machine, and then we say from base64. So we say here inside the recipes what we want to change or how we want to process this input. So we say convert it from base64. So it's gonna convert it, and it looks quite decrypted or quite random data like this. We come back to our code, And we continue. So okay, we have taken that and converted from base64, and now that is saved inside the variable b script. Sure, let's continue. Then it says, okay, again, he's saying that ignore certificates. So it looks like it's always having a self-signed certificate. And then a DLL URL. That's an interesting name because DLL is used for is dynamic link libraries. They are executable files that basically includes a malware. So it might include a malware. It's an executable file like an exe file. So that is the link for it. Okay. Let's continue. And then they say here something called RC4 key. And they are basically equal to this or the bytes of this one. RC4 is a known encryption algorithm, encryption and decryption algorithm. And it's easy to implement. At the same time, it is quite strong encryption algorithm. And we see here there is the function called RC4. And here's all the code to perform the encryption and decryption. As you can see, it's quite small. So we understand now that he's using RC4 algorithm. We don't need to understand how he does the code. We understand it's RC4. We can close that here. And then we see here something called decomp, maybe decompression, decompile. Let's see. And then he goes through, as you see when I'm reading the code, I'm not really reading every single line. I'm looking for clues and keys to understand what this code might be. I don't need to understand every single word. If you are not a malware analyst before and you haven't read or analyzed PowerShell code, you can still look for keywords that makes you understand what the whole thing is about. It's like learning a new language, right? You understand you understand the whole sentence from some of the words, keywords that makes you understand. Oh, so probably he's talking about this. This is the whole idea. So we go here and we can see something called compression, gzip, stream, and then decompress. So it looks like this decompresses from gzip. So now we know that this decomp basically decompress from gzip. Or gzip decompression. Gzip is a known compression algorithm. Okay, and then we see here he takes the B script and then he use RC4 with the RC4 key, and he decrypts this code. RC4 as an encryption. You use the RC4 and it does encryption if the data is decrypted, and the same exact code can encrypt or decrypt based on the status of the data. So if you give it like plain text and used RC4, is going to encrypt it. You give it the encrypted text and use RC4 with the exact same key, it will return it back to its original state. So it goes both ways. Anyway, we have the key up here. And we know it's using here an RC4 algorithm. So let's come back to our recipes up here, and we'll search for RC4. And we'll put the RC4 here, and this time I'm going to put the passphrase as the whole text. Sure, we have reached something more random bytes. Let's come back to the code. So we come back to the code, and you can see here after that he's using gzip decompression to decode the B script. Let's look at our code and see if that will help. So we search for gzip. There's actually something called gunzip. That is basically the decompression for gzip. We call it gunzip. Okay, let's put it there. And we see here a plain PowerShell code, invoke load PE, and there's some long code up here. From the name of it, just load PE is basically PE is short for portable executable, which means any program, any exe or DLL file, and load PE might be loading that file into the memory. So basically, it's like doubling click on an exe file where the Microsoft Windows will load the whole executable. It will create basically a whole process and will create the whole virtual memory, but then it will do what it's going to do is it's going to load that PE file, will load this portable executable file into the memory, so it's going to be able to be executed. This is quite a long process. It's not just copying the file to the memory, it's loading it might change a little bit how this file look like in the memory from how it was as a file. And getting some programs, getting some DLLs, loading some libraries that it uses, get the Windows, the APIs of these libraries, or getting the functions of these libraries, provide them to the actual program that wants to use these functions inside these libraries. It's quite of a longer process. Anyway, we can see that from here we can understand that this is exactly what it does. It loads a library or a program into the memory and basically do the whole simulate what Windows will do to load that library into the memory. We can see that it writes some data to the memory, it allocates some area in memory. You can research these commands as well, you can see what they do, and basically we don't need to read everything, but it is basically what it does is that it loads that program in memory. Let's come back to, so that is the first part. We're able to take that code and go through the reverse engineering, basically the PowerShell code, and able to convert it from base64, RC4 decrypted, and then decompress it with gunzybe, and we got the PowerShell code. Let's continue and see what he does with this code. So next step, he basically go here and downloads the DLL malware up here. This, of course, this URL doesn't work anymore, but we understand the idea. It downloads the malware, and then it uses RC4 again to decrypt that malware. So it decrypts it, and then after that, it goes up here and start using this invoke loadbe and loads that file. So it takes the base script data that we have just analyzed, it's basically executes it, which basically initializes the invoke loadbe function, and then it uses invoke loadbe, so it uses the function inside the base script to load that DLL file of the malware inside a specific process. So probably it injects it inside another process, or basically start a new process of CMD and inject that code inside of it, or just directly loaded inside this PowerShell image. So either it loads it inside this process, or it basically executes cmd.exe. As you can see, start process means start a new application, and it's cmd.exe, and then it takes its information, it takes the process ID, and basically inject the malware files, the malware data inside, or the malware DLL inside this program, and basically invoke loadbe. Generally, when you are loading a library inside any process, you will start, or the Windows will automatically create or not create a new thread, but it will execute the entry point of this library, a kind of initialization code at the beginning of the library, and this code is basically where the malware resides. We do have here the malware. I have the malware, and you can analyze it together, not of course in this little demo, but you get the idea. So we're able to follow exactly with this malware, and you can see that this malware has never touched the hard disk throughout the whole process. So it started with a Microsoft legitimate application loading an XML file from the memory. This file is not going to be saved on disk. This file basically the decoded version of it runs PowerShell. It makes sure that the serves, make sure that it allows for self-signed certificate, and it downloads another PowerShell code and executes it inside the PowerShell process. This PowerShell process as well takes another script from base64, decrypted with RC4, decompress it, and that is basically the PE loader he does have. And then it takes another malware, downloads it, and decrypt it with RC4 with the same key that we have, and start the CMD process and inject that library inside of it, or inject it directly in the memory. And that is basically the full malware. And of course, the malware continues from there, and we can continue the whole analysis from here, but you get the idea that the whole file is attacked. It's able to move from one place to another. And this is basically the process of malware analysis. We're able to understand not just how the malware works, but we're able to decrypt the data we have. If we have a bcap file, we know that this bcap, this data is basically encrypted with RC4 with that key. So we're able to decrypt the communication between the attacker and between the PowerShell script, and basically find a new sample of that malware. Also, if this malware communicates with the bcap, with the attacker, we can take a bcap file and we can analyze how this communication works, what commands the attacker sent, and so on. So that's it for this demo.